Good morning. I'm going to try and remember to record today and to do screen sharing. Let's see here. Just give me a second. Yeah, okay. So, good morning. How are you? How is everybody?
Good morning. I'm fantastic personally.
Good, good. Well, I've had a very hard week, so I'll tell you a little bit about it here in a second. But yeah. Okay, I think according to my watch, we're about to begin. Um, we should be recording. I should be screen sharing. I think everything's better today. First thing I want to say, next week is an official school holiday, next Monday. So I guess what I'm going to do is I will record the meeting without anybody since we can't have classes or we're not supposed to have classes that day. So I will try to record the meeting and get the lecture up. Um, um, Sometimes I feel it's a little harder doing it without students, but that's okay. Anyway, there will be a, a lecture and whatnot for next week, even though we are officially off on Monday, a week from today. Okay, having said that, let's see. I will say I've had a lot of trouble this week. I'm a little bit behind on things as a result. I I tried to do an upgrade of VirtualBox, I think, and it did not go well. Um, and then I tried to delete everything, undo all my upgrades, and for some reason that did not go well. Um, a part of the problem was that I was using an outdated an outdated version of OpenSUSE, and some of the upgrades didn't work right. Part of the problem was that I was out of disk space and I was using um, shared disk. I think that's the word in Windows. I was using NFS, a disk, the Unix word, a remote disk. And I think I accessed things from the wrong computer as a result. That was my own fault. Anyway, not everything, things didn't go right. So I went out and um, so I ended up upgrading my number one, my desktop system, the system I use day to day. I had to upgrade it. Of course, that meant I probably wanted to get another disk drive or a soft disk. I I ordered a disk. Um, of course, when it came, it was I didn't have the right slots in my machine for that disk because I have very old motherboards, and they didn't have the what is it NMVE disk slot or something for the newest soft disk drives. So that wasn't to be. So desperately, I went out and I bought a disk, a Samsung soft disk, and 2 terabyte. And that worked pretty well, except it just didn't run fast enough. And I don't know why it didn't run fast enough. It should have worked great, but it just didn't. I have a suspicion that my computer is old enough that the USB ports are not performing like they should perform. They're doing just fine, but they're slow compared with rated USB 3.1 specs. So I had to make do with some soft disk I had around here and splice them together, and I'm up and running, but barely. And I guess that sort of thing is, that happens. It's typical. It's embarrassing when it happens. Shouldn't happen to me. And there are systems that really have to be up all the time. And sometimes our uptime, sometimes it's pretty good, sometimes it's not as good as you'd want. Who was it? We had a couple major outages, in the last couple months. I don't know, big companies, people like YouTube or whatnot. Yeah, it wasn't YouTube, but it was, people that should just never be down have, I remember we had basically some sort of virus or worm get into some systems and really, really, really screwed up somebody. And lots of money can be lost really fast when companies like that are down. Okay, enough for those remarks. So what we're going to try and do today, which I'm not well prepared for, but we'll play it by ear. We want to talk a little bit about editors and RMS, whatever RMS is, or whoever RMS is, and shell scripting, and maybe writing man pages, just a little bit. And then we'll talk about the material in chapters 5, chapter 6, and chapter 7 of our textbook. Now, these chapters are actually a pretty fast read. A lot of it is review material. Some of it probably isn't, or it may be review material that you're not that familiar with. Okay. Well, let's start with RMS for the moment. RMS stands for Richard Stallman. I guess we can go down here. And I do want to mention Richard Stallman a little bit. We'll go over here and look at his Wikipedia page or something like that. Richard Stallman. Okay. Linus Torvalds often gets credit for Linux, and he deserves credit for Linux. And he wrote the kernel to Linux. However, the idea of open source software started back in the 1940s, 1950s. 1940s, there wasn't much computing done, but 1950s, because people didn't realize software was worth money. So the first software anybody ever wrote was quote unquote open source. people like IBM were giving away their operating system because it wasn't worth any money. I mean, they sold hardware and, it was just sold as a bundle until one of their engineers, a guy by the name of Mandel, moved across the street and started building the same sort of hardware and selling it with IBM's operating system. But but in the early days, most software was, well, we didn't have the word open source, but it was open source. And then it started to get closed. And in particular, with the advent of PCs and Bill Gates, Microsoft, Apple, Stephen Jobs, Stephen Wozniak, the software started getting proprietary. And one of the moves against that movement was started by Richard Stallman. And one of the things he did was to write the general public license, which is the way much of our software is, open source software is licensed today. It's a bit of a virus in terms of a license, because what it says is if you get software, you improve it and you distribute it, you must make the source code available for the software, for your changes. So nothing can ever slip out of the public domain, so to say. And Richard Stallman called that free software, as in freedom, and started something called the Free Software Foundation to govern all this. And they wrote a lot of Unix utilities. Many of the utilities used in Linux came from the work by the people associated with the Free Software Foundation. This was a big advance in open source licensing. There's two forms of open source licensing, as maybe you know. There's the GPL type licensing, which was really the brainchild of Richard Stallman, and there's what's sometimes called MIT or Berkeley or artistic site licensing, which basically says, here's the source code, do whatever you want with it, but don't blame us if something goes wrong. So there's nothing that says this has to stay in your changes have to be public. That's not in the artistic type licensing. Some software, there's a place for both types of licensing. Okay, anyway, Richard Stallman, his other great advance is he was a key figure behind the Emacs editor, which is an editor we'll talk about a little bit today. And I will say a word or two about him. Richard Stallman is a controversial figure. Anybody that's ever met him has had a fight with him, I think, myself included. He's known for being hard to get along with, but and in recent years he's had some trouble over. Well, if you've got a Wikipedia page, you don't want to hear the word Jeffrey Epstein on your Wikipedia page. Need I say more? Okay. However, he's done an awful lot for the open source software movement. Now, he called this free software. To this day, he wants all open source software to be called free software. Free software just didn't make it as a good marketing name. So a few years later, Eric Raymond and Bruce Perens and somebody else, I can't remember who, had a brainstorm after a conference or something and came up with the name open source. That was back in the 1990s. That's a name we use, well, most of us use to this day. except Richard Stallman, it's still free software. Okay. Going back here, let's talk a little bit about editors. If we go to your textbook, on chapter 5 of your textbook, it will talk about text editors, and there are 100 text editors for Unix or for Linux. We've got, I don't know, there's Kate, there's Joe, there's Pico, there's, choose 4 letters and you've got a text editor. There's a lot of text editors. I can't remember what text editor was used in the earliest days of Unix, but it didn't work terribly well. So 2 years down the line, I mean, we're talking, instead of 1969, we're probably talking 1971, 72. Somebody, maybe Bill Joy, wrote an editor called VI. And VI is used to this day as kind of the #1 leading editor in Unix or Linux. There's been an improved version of VI written called VIM. Everybody today uses VIM, but we all say VI. And if you type it in on the keyboard, you type VI. I guess VIM works, but everybody uses VI. Now, the nice thing about knowing some VI is a pain. Let me see if I can find uh-oh. Let me see if I can find a screen here. Okay, I don't really want to use that screen because I'm rooting in that screen, but we'll use this screen. Let's go. Okay, VI README. It gives you something that looks like this. It's kind of what you have is what you see type editor, but not really, because it has various modes to it. Remember, this thing was written in the 1970s or something like that. And when we were just getting our first soft screens, and they weren't bitmap screens. They didn't, they were very limited what you could do. So the result is there are modes in the editor. Like if I want to search for something, I type a slash, and then I type R, and capital R, slash return, slash return. Okay, and the command for like adding to the end of the line, I think, is capital A. This is more. The command for saving my work would be, I can't type that command. If the command to save my work would be ZZ, capital Z, capital Z. If I type capital Z, it types. What I have to do is I have to hit an escape and then type capital Z to save my work. And that will save my work. Now, in my case, I don't want to save the work, so I will type a colon Q, and I bet that doesn't work. Let's try that. Nope, that doesn't work. So I type colon or escape, colon Q, exclamation point. Now that does not save this because I didn't want to save it. So, and that works. Anyway, the commands for Emacs or the commands for VI are very much like that. They are they're a little cryptic. I don't know VI very well, but I know it well enough that I can use it. I mean, I would never be a programmer using VI because I don't know it well enough to, like, I've got friends who program and their VI is their editor. I don't know Emacs well enough to do that, but I know I know VI well enough to do, to use it in my day-to-day life. I can edit the password file. I can do quite a bit. And you don't need many commands. So get used to using VI. Why use VI? Joe or Kate or whatever is so much easier than VI. So why use VI? Well, I'll give you 2 or 3 reasons. VI is on every Linux or Unix computer. Joe or Kate or Pico are not. They may be on your computer because you install them on your computer, but they are not on every editor. VI is almost universally on just every Unix machine you'll ever touch. The other reason for learning VI, or another nice thing about VI is it's cryptic, but it's actually a very powerful editor. One of the nice things about VI is I can edit a file that is really long. I don't know how long, but I've certainly edited files of 10 to 20 million lines. You might ask why I would want to edit a file of 10 to 20 million lines. Well, I don't want to edit, but but often you get data files, like say the DXF file from a CAD drawing. If you turn a CAD drawing, like from AutoCAD, in its export format is called DXF. It's just an editable file. If you have errors in that file for some reason, and they get in there, you need to edit that file a little bit. VI is a powerful tool for doing that. And really, getting a 10, 20 million line file is nothing. It's easy if it's like a CAD file that it comes from a CAD drawing. A lot of GIS, geographic information data, set data is that long. Actually, just some oceanographic, if you do oceanographic experiments, some of the time series nowadays must be getting that long. I'm sure they are So VI is nice because you'll find most of these editors, I don't think they can edit anything that long. Okay, our other editor that I dearly love is called Emacs, which was written, which Richard Stallman takes credit for writing, I think. He added a lot to Emacs. He came up with GNU Emacs. I think he started with the base that was written by somebody else, I believe. But he did great work with Emacs. Emacs is an editor that a lot of people love and a lot of people hate. People make jokes about Emacs. It's the only editor that is truly an operating system. um, it People make jokes about it using too much memory, various things. It's a powerful editor. Let us go up here and give you just an example of Emacs. Now, one of the things I can do with Emacs is I can have various buffers. So I can be editing on more than one file at once. If I want to edit on another file, well, let's see. I don't know what this file is, but hopefully it's not embarrassing. Okay, there's another file, and I can just go between one file and another file, and I can basically be editing on a lot of files at once. I can, and it is truly kind of what you see is what you get. The only problem with it is it does take cryptic commands. However, you can move your cursor, you can use the delete button, the backspace button, the find button, and they've got a lot of buttons up here you can use. They've got nowadays they have pull down menus. The early Emacs did not have pull down menus. And there is a non-X Windows version that does not have the pull down menus. You have to remember lots of cryptic commands. But the truth is you don't need to remember all that many commands. I mean, there's only 10,000 of them, and you can probably get by knowing only 20 of them and do pretty well. Okay, let's see. Another thing you can do with Emacs, just out of curiosity, you can open a new frame. Oh, a new frame is, we call those windows in the rest of the world, but they call them frames because they used windows for another word. So you can, basically, you can have a lot of different windows open. You can go into something called shell mode, and this is cool. In shell mode, okay, now comes one of my cryptic commands. If I type Control X1, that gets rid of that division there is called a window in Emacs language, and that gets rid of my window. Okay, so I get, oh, and now I'm in, basically I'm in shell mode. So if I want to type a command like, oh, wow. More, oh, I don't know that more is a good command. Let's type cat, etc password file. Now, the magic behind this is I have captured the output from that would normally go to the screen. When I do the cat command, it is now captured in that buffer. I can save that buffer as a file. So if I want to save that guy, well, let's go up here. There, we'll mark this. We'll go back to the beginning of our text. It's moving slow. Ooh, what happened? Oh boy. There we go. It's moving slow. I'm not sure why. But I go back to the beginning of this. I'll type a Control W. That should kill everything that I just put in there. Okay, that just killed the top of my text. Now I have nothing but this. Now I could save that as a file. Well, actually, I can do that with, there's a guy up here, I bet that will let me save that. Save as. Oh, and it brings up weird stuff. So you can do it in a graphical format. I'm more used to doing it like like using my keyboard. Control X, Control W, and we'll call this TTT.txt. Okay, that saves my add new line. Oh, I guess I don't have a new line at the end of my file. I'll add it. Okay, that allows me to save that, and I can then work on that file, which is cool. The other thing about shell mode, well, the other thing about Emacs is Emacs has a programming language built into it. And you can actually write more Emacs code. If Emacs doesn't have something you want, you add it. Well, it takes a little bit of effort. They have a programming language called Emacs Lisp. Lisp is an old honored programming language. Until recently, it used to be the programming language of artificial intelligence. It is cryptic. It's kind of hard to write. It's got parentheses every place. But it's a beloved language. It was the our third oldest programming language. Well, maybe fourth. The first one was Fortran. The second one was COBOL. The third one was Lisp. But then we forgot there was another one called Plankton or something that was done in Germany during World War II. So nobody counts it. For one thing, it was never really implemented until 2000. Okay. Anyway, Emacs takes a little bit of learning, but it's a wonderful editor as far as I'm concerned. You can edit very, very long files with Emacs. Not as long as with VI. But you can edit files of 10 million lines is no problem. Maybe a lot more. That was years ago. It was maybe 10 million lines. I'm sure it's not more now. And what you did is, if you had a long file, is you'd split your file into chunks, and then you could edit each chunk. I once had a little project where I had to take 300 Fortran programs written in Fortran 1966 standard, and port those to a new computer. There was more, and I only had a couple weeks to do that. There was more code there than I could physically look at. I used Emacs. Basically, I wrote a lot of Emacs macros or Emacs language to edit these files blindly. And so a lot of this was code I never looked at, and it actually ran. Yeah. That's the sort of thing that Emacs can do. Emacs also has a lot of add-ons. You can do networking in Emacs. Yes, networking in an editor. But you can do networking in Emacs. Oh, you can do web browsing in Emacs, and they have added graphics to it, so you can do graphics too. I basically do not like their browser very much, but it would be handy for some things. I can't find it now, but there's a spreadsheet written in Emacs. Once I wrote a very special application in Emacs because people they wanted to capture data from trees of some sort. Let's see. God, it's been too many years ago. But the problem is they didn't like a traditional database entry type system that brought up lots and lots of screens. And they wanted two different user interfaces. One that the really skilled people could use in an office, and the second one that people could use on a little tiny laptop that they'd take out in the field. And I did the whole thing in Emacs. Man, yeah, it worked for, as long as they needed it, number of years. Okay. The The other thing you can do with Emacs that is kind of cool is you can write macros. And I will just show you one little macro here. Um, this one. I gotta find I gotta find the guy I want. Okay. In this, I put in some information once a day, every day. And I just say it happened at midnight, but it doesn't matter. Okay. Suppose I ran out of days. I need another month. I actually wrote a macro and I named the macro. It's a little bit of Emacs code. And we will go down here with escape 30 says do the next command 30 times. Escape X next day. And it is sitting, it's waiting, it's doing its thing. I've got a problem on this system. It's just too slow. I can't. I'll have to search on that. But wow. Well, maybe this won't be that impressive. Okay, I got something that's not working right. We'll come back to that. Whoops. I am frozen. Okay, well, okay, the next thing we will want to talk about after talking about editors is Bourne shell scripting. Now, I do want to say, okay, there was something wrong. There's something wrong on my brand new system. It is slow as can be. This thing happens like lightning, um, and I don't know why it is so slow. Um, okay, I'm just getting rid of a few lines here. Um, when I wrote this, I have it put in a blank line that it shouldn't put in. I made a mistake in this and I never fixed it. Okay, let's do one more thing though in the Emacs. Um, I want to add that big black to all of my lines here. So what I can do is I can write a little macro. The first thing I'm going to do is I'm going to put in one line with big black by copying that line there. If I type a control space key, that marks where I'm at. I type a control E, that takes me to the end of that line. I type a escape W, and what that does is that copies the thing that I marked into the what's called the yank ring, or it basically keeps it in a copy area for me. Okay, if I go down another line and I do a control Y, that yanks that guy. Okay, so good. Now, I want to do that, say, 20 times. What I can do is I can start a macro by typing control X, left parenthesis, that, and it says down here at the bottom of my screen, defining a macro. Now, my macro is going to be very simple. It's going to be one arrow down and then a control Y, which is yanks that that thing that I'm copying. That's the whole macro. Now, I'm going to do a control X and a right parenthesis to close the macro. Now, I know the details are hard to remember, but just get the idea here. I have just written this little macro, and I think it's, I want to execute the macro by using a control X with the E key. Okay, control X, E. Well, now let's execute that 20 times. So I type escape 20. I probably should have done 5 times because something's really slow here, but, and then, so I hit escape 20, and then I hit control X, E. There, popped in 20 times. That is pretty cool, I think. Escape X 5, or escape 5, and then I type control E, and it puts in another 5 for me. That is pretty cool. And if you think about it, you can do all sorts of things by like writing little macros. Like you can take a table and you can flip the columns in a table. There's all sorts of things you can do really fast writing little keyboard macros. It's a pretty cool thing to be able to do. Okay, the next topic that we want to talk about, oh boy. Okay, the reason I'm putting a lot of emphasis on the editor here is there's two things we want to do with the editor. The first thing we want to do with the editor is often in Unix. In Unix, we do not have a registry file like you do in Windows, where everything's kept in this registry database and they give you a user interface to do everything. Instead, in Unix or Linux, everything is kept, or not everything, most things are kept in flat files, ASCII files, very simple ASCII files. An awful lot of them are kept under /etc. And the way you make changes in your system is you just go in and edit the files. In many cases, like, well, we don't do this anymore, but let me go down here. In the old days, when I learned Unix, when I wanted to add a user, what I would do is I would go into, let's use vi/etc/password file. And I'd go down to the end of this file, and that is terrible. Let's use Emacs because it's easier to read. Now, I'm a little reluctant to use Emacs when I'm working as root, but I do it. And what you would do is you just go in and manually edit this. So if you were going to add a new user, you just add a new user here. New user, :X. That's where the password goes or something like that, but we don't keep the password there anymore. That was in the old days. We've got a more secure method of doing that. I'd put in the new user number and I'd just type it all in. And then I'd have to go back and do a lot of other stuff. Whoops. No, I do not want to save what I changed there, or I will really be screwed up. Okay. And then you'd have to make the guy's directory and maybe make a group for him and do some other stuff. But you do it all with an editor. Today we have in Linux, we have a program that does that for us. But we used to do it manually. There's still a lot of things we do manually. When you set up a network, if you set it up with a static IP, you probably have to edit a file where your network configurations are. So there's a lot of reasons we edit things manually, and the programmers need to do this all the time, but so do systems administrators. The other thing you need to do all the time, or at least if you want to be a good Unix systems administrator, is, oh, this was a dumb one, is to write shell scripts. Now, this is a very simple shell script. In fact, I think there's only about 2 lines to it. And I'm emphasizing this one because this is one I use every day, or I use a lot. There's 3 lines. It's an awful shell script in that it's too specific. It only does this for me and nobody else. But that's good enough. And the thing about writing shell scripts is I like people to be really comfortable writing really simple shell scripts. It's cool if you can do big, elaborate, fancy ones, but shell scripting is an awful language. And and what a Unix systems administrator really needs to be is fluent doing simple shell scripts. The big elaborate ones, it's not that important. I mean, yeah, it's nice, but it's not that important. But the being able to write the simple, being comfortable writing a simple shell script is really a valuable tool. It will save you so much time and effort and energy. It's this one's what, half a page, and half of that half page is comments. That's typical of the sort of thing you need to do in order to be able to automate backups, automate this, automate that, or sometimes just as a memory aid. Some of these commands get to be, you know, that long. Well, not that long. I mean, they get really long and ugly. And if you're typing them in all the time, well, yeah, I guess you can learn to remember them, but it's easier just to write it all in a shell script that you execute all the time. So, what shells do we use? Now, we studied this in Unix, right? There's different shells, I believe. What is a shell? A shell is the program you use that you type your commands into. If I type the ls command down here, the first thing that reads that command is a program called I think, bash shell. And that bash shell then, if I have like a star here, the bash shell then takes that star, expands that star to be whatever the star is supposed to be, and sends that to the system, calls up the ls command, and does its work. So there's an intermediate command there between me and all of these commands, and that's called the shell. And sometimes the shell does do useful things for us, like it can do wildcarding. Here's something the shell does. If I type a Control A, it goes to the beginning of the line really fast. I type a Control E, it goes to the end of the line. If I type LS and I type tab key, it gives me all the options for files that I could use. Read me, oh, I don't want to type that thing out. I hit the tab key. It's my shell that is expanding that for me. It's nothing else. It's the shell. Okay, there are various shells in Unix that you can use. One of them is, the one that we use today is called the bash shell. I will sometimes call this the Bourne shell. But there are probably two basic types of shells in Unix. On my machine, there's probably a dozen shells. There's one called SH. SH stands for the Bourne shell. The Bourne shell was the first shell ever written, and it doesn't actually exist on the machine. but it does say that I have a Bourne shell, even though I think that's a link to the bash shell. But there's a Bourne shell, there's a corn shell. Whoa, corn shell. Well, that should be this way. KSH, I believe. There's I think it's public domain corn shell. It's not on my machine. There's a C shell. There's a TCSH shell. There's a TCL shell. There's a lot of shells. They pretty much all end in the letters SH for shell. Anyway, there are many, many shells in Unix, and there are families of shells. The two big families of shells are the Bourne shell, which was the very, very first shell, and its family includes the corn shell, the public domain corn shell, the bash shell. Nearly everybody today is using the bash shell. Most Unix users, I believe, are using the bash shell. Almost all Linux users are using the bash shell. If you have a Macintosh, the Macintosh is based on FreeBSD, and the BSDs by tradition use the C shell, but Apple uses the bash shell as its default. The other set of shells are called the C shell, and that's things like CIS. And there's a dozen of those C shell things. Now, the reason I mention this in terms of families is there's two different programming languages. There's a C shell programming language, and there's the Bourne shell programming language. And all the guys in the Bourne shell family use the same, 99.9% the same shell programming language. So if you program a bash shell or a corn shell or a Bourne shell, the programming language is the same. There are different features, like this thing I showed you about tabs and about moving spaces back and forth. Those are in the corn shell and the bash shell, but not the Bourne shell. So each shell gets better with time, but they're backwards compatible. The programming languages are pretty much the same. I should know, I probably hit every error where they're not the same, but they're pretty much the same. Okay. Now, I should go over here and mention, when I type in this big command, more, readme, tab, oh, that more is wrong. I typed in most, I meant more. So I could go back here with maybe a Control R, whoa, space? Yeah, I did a Control R and a space for, Control R is reverse search, and then I will do a backspace, backspace. The backspace didn't work, but we will do a Control D, MO, Control E. Okay. And I can do my command then. Okay. Cool. Now, all of those editing commands, where did those come from? Well, by default, those are Emacs commands, because David Korn, who wrote the corn shell, liked Emacs. And people that wrote the bash shell, that was originally part of the GNU project, which was associated with Richard Stallman, who likes Emacs. So a lot of those, you'll find Emacs commands throughout the Unix operating system at times. Sometimes you can get rid of those because there's a global variable that you can set for editor that is, by default, it's Emacs, but you can set that to VI and maybe use VI commands. Anyway, by default, it's Emacs commands. And there's actually a library. So if you write your own programs, if you call the library, which is called LD read, as I recall, you can actually make it so when you so that your programs can use all of these Emacs commands to help people input data in your programs. Okay. That is our brief discussion of shells. And I do want people to get some experience with shell programming. I hope the assignment, I read the assignment, I don't remember it now, but I hope the assignment does push you to write a shell program or two. And I hope that during this course you will write 3 or 4 shell programs, you know, or more. A shell program a week doesn't, keeps the doctor away. It's not a bad idea. I mean, these are things I write all the time. Little, simple, dumb things. Another reason for writing shell programs is sometimes you want to schedule work to be done when you're home in bed sleeping. And there's a function for that called cron. And really the only way to set up a cron job is to write a shell program to do what you want. Usually they're very, very short and simple, but you do need to write one. Okay, let us take a 10-minute break here, or an 8-minute break. We'll be back at 10:10. Okay? Te Pusam at Batu Caves. Okay, I will be back. Oh. Okay. How are people doing in general? I told you about my woes and problems. How's everybody else doing? Do you have your systems, do you have a system up and going that's running Almar Linux or Red Hat or Rocky or something like that? Is anybody there?
I'm not sure about anybody else, but I have mine up and running after having to fight with my antivirus over it.
Oh, okay. But it's going okay now.
Yes, it's going perfectly.
Good, good. Um, Anybody else?
Sorry, what was the question?
Oh, do you have your system up and going?
Yeah.
Yeah. I I will say, I like VirtualBox. I like hypervisors. Actually, I do a lot of production work in hypervisors. But I will say they do not feel, when you're sitting at a desk using one, they don't feel as fast and smooth as if you're sitting, as if you're running bare bones hardware. And do keep that in mind, that, a hypervisor performs well, but they're not quite the same as if you're actually sitting at a machine. Particularly the hypervisors, I think, they've gotten better and better and better, but they still have more problems with I/O and video. They really do well as a computation machine at this point, which is why the whole world's using them. But the whole world's using them as computation machines, not as much as sitting in front of them. They still work well, though. Okay, let us do our thing here. We'll go back here and let's take a quick look at what we want to do here. I have one other oddball thing I want to talk about a little bit. That's relevant to Unix systems administrator that most textbooks don't talk about and your textbook does not talk about. And your textbook is not at all unique that way. Unix man pages. Now, your textbook tells you to use the Unix man pages. So if you type in man bash, now bash is a bad one because bash is about, really, really long. But if I type in man bash, it will tell me everything I ever wanted to know about Bash and maybe a little more. Now, it's a reference manual. It's not a, it's not a, it's not a tutorial. It's not a how-to. It's a reference guide. But but it's really nice having a reference guide at your fingertips. And your Unix man pages are so valuable. Some of them, like Bash and PS, are pretty long. Others are quite short. I don't know, man space. How about sort? Nah, sort's probably a longer one. Well, okay, how about VirtualBox? Huh, it's not there. VirtualBox Manage, which I don't know what that's for. We probably may not use that in this class. I don't know. What it is it allows you to type in things, give VirtualBox commands without using the graphical user interface. There is no man page. This is sinful. I think there should be a Unix man page on it for every command, even if the command just says, go to this website. There should be a man page for every command. Modern people, younger programmers, don't like Unix man pages. And, you know, way back when, you know, in the 1980s, there were people that were saying man pages are antiquated. We shouldn't use Unix man pages. It doesn't matter. Man pages are useful. And so, you know, I hate to put commands on my machines that don't have Unix man pages, especially if the command is locally written by a local programmer. If you don't have a man page, how on earth are people supposed to know how to use it? Well, it is true. Some of these commands like this probably have, I don't know, we'll try it, probably have a -H or a -H help or something like that. That's become a tradition among the GNU people, but still Unix man pages are really useful. Now, I think they are stored down under an area called SRU / I don't know. There's something down there. Oh, here, share. There's some files here. The files under /usr/share tend to be auxiliary files that programs need to run. So like if I'd look under the share area for Emacs, I would probably find a lot of the Emacs code down there. Site, I don't know. We'll just look at one of these. And you see here is Maple. And that is the code for Maple mode syntax table, whatever that is. I don't know what it is, but that's the code for it written in Emacs Lisp. And if you see a lot of parentheses and a lot of stuff that, you know, takes a while to get used to, well, that's the way Emacs Lisp works. That's the way Lisp works. Lisp is awful for parentheses, but however, we wanted to go to man and see if there's something down there. Well, there's a lot of files down, there's a lot of directories down here. And what we will see is actually there's man pages DE. DE are probably German man pages. ES must be Spanish. FR is French. I don't know. PL, maybe Polish, I'm not sure. Anyway, there's a lot of foreign man pages. The English ones are kept in places like Man 1, Man 2, Man 3, Man 4. I'm not sure what the Man 3Ps are. I'd have to look at those. And those man pages, there is a rhyme or reason to what's kept in Man 1 and what's kept in Man 5. There's user commands are kept in Man 1. The documentation for user commands are kept in Man 1. System commands, I think, are Man 5. I forget. Or maybe that's file formats. File formats are kept in Man 5 or Man 8. Well, it would tell us under Man, probably. I hope. It tells us someplace where nope, that's Texas status. Okay, well, anyway, if you go down in these, you will find Man 1 as an example. There's a lot of files down there. Now notice they're kept in a .dgz format. The GZ is what? That's a compression program, I believe, called gzip. So if I take the man page for GhostScript, let's copy this one. GS dot. We're going to copy this to my home directory where I can't do too much damage to it. Now I've got so I could do G unzip GS, and that should unzip that thing. And what gzip is it's a compression program. And it is unzipped. Then if I take that into my editor, I get something like this. And what I see is that these are kept in, well, here's the description. Let me put that in the background. That goes up there. And let me do this. Okay. And if I look here, I will see that this says GhostScript is an interpreter. Oh, GhostScript up there, that looks like that line there. Name is GhostScript, and it says PostScript sort of thing. That looks like that line right there. Okay, And anyway, what this is the man pages are written in a markup language. We have lots of markup languages now. HTML, XML, JSON. Every day I run into a new markup language. Well, this is an ancient markup language called INROF, TROF, GROF. It goes under various names, but they all end in ROF. And it's a markup language, and this dates back from before we had what you have, or WYSIWYG word processors. Before we had those, for a while, we used markup languages to write our resumes and our papers and everything else. And, you know, it meant that you had to put all these codes in as you type things in. And it's a pain, but there's ways of cheating. You can do it. And it is a valuable thing to be able to write a man page. So I leave it at that. I believe over here, and I will put a link to this in the D2L site. There is a document for how to write a Unix Linux man page, a quick and dirty method. Basically, what I do is I take somebody else's man page. At one time, I actually learned INROF, TROF, and could write it. But it's kind of awful because they've got a lot of specialized macros and whatnot. So what I usually do is I take a man page, I take all the content out and put my own content in and use their markups. And it works quite well. And that's all explained in this hour-long video, if anybody ever gets into writing Unix man pages. Because it is something valuable, especially because a lot of programmers don't like to write their own man pages. And if you're supervising them, that's fine. You can shoot them if they don't write their own Unix man pages. If you're not supervising them, you end up writing their man pages, which is unfortunate because they usually do a better job than you can do. Okay. Next topic here. Well, we're not going to talk about this very much. This is all the stuff in Chapter 5. The main thing we did not cover here is file redirections and piping. Those are critical issues. You probably see me do those all the time. Unix commands are meant to be strung together, and you know, one helps another. Suppose I do something like this. Whoop. Oh, that's not there. What do I have here? Okay, here. Now this is sort of dumb. I would probably just do more on this file, but okay, there's a log file. Now that's got, oh, that doesn't have much in it at all, but suppose it had a lot of stuff in it. I want to get the number of words, number of lines in it. I do pipe that into WC. Now I could actually, in this case, I could type WC space and then the name of the file. But the idea is I can always combine commands. I can pipe those. If I want this thing in its own file, then I get, I save that into a file instead of, instead of getting it at the screen. Piping and redirection is, crucial. You guys, I assume, did this in your Unix class. Read chapter 5. It's all in there. Chapter 6 is on local user group or users and groups, managing users and groups. This is crucial to your security on a Linux system, and or a Unix system, and users are the name of the game, and user access rights. So one of the things you need to do is to be able to add users to your system. There is a command to add users to the system. Let's see if this command's still there. Okay, there used to be a command called add user. Add user had some errors. It wasn't a very good command, so people rewrote that and they called it user add. Whoops, I better become root to do that. Let's go over here where I'm root down here. Oh, I happen to be using my SUSE system, but the commands are identical on, every, I won't say every Linux I know. But they're identical on every distribution that comes to my mind offhand. They're identical on all the Red Hat distributions, on and all the Debian distributions that come to my mind. Anyway, there's a command called user add. Let's do a man page on it because it better be a man page. And indeed, there is a man page. And it describes how you do stuff, how you add things. I don't know how well the password option works. I've never gotten that to work right for me. But in essence, what you end up doing is to add a group or add a user, what you need is you use user add and group add. Okay, let's do this here. Let's go to, let me think about this, but yeah, no harm done. Let's go to /etc, and there will be a file there called group. And group basically has all the groups on your system. And groups have certain rights. There are group access rights. So if I want to add a new group to my system, boy, I don't do this very often. Let's do a man page on that. Well, let's do this. Let's go to our friendly editor. Notice I'm typing in the path name from hell here. Oops. I don't know what I want there, so let's type in an ls command. Notice how much I use this editor. That was going to be an Emacs command, but I didn't know what I wanted to type in for Emacs. So I back out of it and I change that into an ls command. I don't know. Okay, here's where we're going to do this. Edit. Oh, let's go back to the previous command. Actually, notice that I can do a Control R. And call back previous commands that I executed before. It keeps a stack. There's a way to govern how, there's a global variable that tells you how long to keep the stack, but it keeps a stack of about 100 commands for me. And of course, you can change the length of that. Emacs. And we will do add user 22. Background. You know, the few fans of, that's not a good one. Oh yeah, the few fans of Emacs live in Emacs all the time. You find me always in Emacs, because it's just the way we work. Okay, here's an example of the add user command. Add user, and we'll just type this in here. I need to know, make sure now, with every user and every group, with every group there is something called a GID. That is the group number. With every user there's something called a UID. That is the group number or user number. And I want to say a word about those. Unix did not, Windows knows you by your username. Unix did not know you by your username. Unix doesn't do much with your username. It just keeps your username in a table in the password file. But it does everything else with your group name or your UID name, your username. I'm sorry, your user number, your UID, that user number. That's really important. Likewise, all the group stuff is done with the GID, the group number. And so on disk, if you have a file on disk and it says the owner of that file, it doesn't say D. Mandel. It says 44345 because that's my UID number. Okay, that's something that is really going to be crucial to us. Now, to add a user, these are the options that I would use. First thing, I want to make sure that we'll be okay here. let's add a user. We'll add a user called okay, let's call this user LLL. And we're going to give them the group 5306. And their name is LLL. Okay. Now, let's see what these guys do. I forget. In particular, what's the M do? Oh, the M is for create home directory. If you don't have the M, it will not create the user's home directory. Sometimes it's very useful not to create the user's home directory, but nearly always you want to create the user's home directory. The only time it's not useful is if the user already has a home directory from another system or something of that type. Okay, the next one is a comment statement, which is basically you always put the user's name here. If it's a big organization, you may put their office number as well, so that you know where to check on them, or maybe their telephone number. The group is their default group, and you put that in by putting the GID of that group in here. 100 is usually a group called users on most systems. And then you have to choose an unused UID number. If you don't choose one, it will use the next number and it just keeps counting them up. It starts at like 200 or something and it just starts, or maybe it's 1,000, and it just counts users up. I never ever do that. And then -D is the directory to be built, and TTT or LLL there is their username. So this guy here would create a user. That's all there is to it. Now, if I go over here, and you have to be root to do this. Notice there's a user LLL. And if I go to my password file, there's a new user down at the bottom, LLL. LLL can now log on to the system. If I'm over here and I do an SU/L, no, LLL cannot log on to the system because LLL does not have a password yet. But let's give LLL a password. The root user can change anybody's password. Everybody else, you can only change your own password, but root can change anybody else's password. Okay, so I want to log on. There I am. I'm LLL. LLL is now a user on my system. Okay. Now there is a command for deleting a user. What is that? Oh no, it would be user delete. And I better, okay, well, I'll do this after the fact. Now, the book talks about deleting users, adding users, deleting users. Never, ever, ever delete a user. One exception is I'm going to delete this user right after the class. I almost never use this command because suppose a user goes to another organization. Do I want to delete them? Yeah, maybe, but their files are still important. I may want their files are still important. The other thing, they may come back to my organization. I've had people that have worked for me, a year now, a couple of years later, a year. I mean, especially you get consultants, they come back all the time. So don't delete your user. Just change their password so they can't get in, or set some other criteria so they can't get in. Changing their password's usually enough. Anyway, I never delete a user. Now, I want to tell you why this UI, I want to say a couple words about the UID and the GID before we leave here. I almost put everybody under the GID of 100. Other people, every time they make a new user, they make a new ID number. So if I have a user who is 44345, I would have a group that is 44345. That user would be a member of that group and no other group. Well, at least as that would be their primary group. But some systems do it the way I do. Other systems do it the way I just described. Debian, Red Hat, a lot of systems, every time they add a new user, they add a new group by default. SUSE, certain other systems, they put everybody by default in the group users. I think the more modern way of doing things is to make a new group every time you make a new user. It makes for tighter security. Remember, I worked in scientific systems, small scientific research groups where everybody was sharing a lot. The way that I do things are very much easier, tend to be easier in that type of an environment. They tend to be, but they probably are not as good in a business environment. And I think over the years, more and more people have drifted from the way I do things to the way to the Red Hat defaults are today. And it's your choice, look at your situation and choose. The other thing that I want to say about UIDs and GIDs is I just said that on the disk drive, you are known by your UID number. Now, I got a disk drive here. It's formatted as, what's Red Hat use? ext4. It's formatted as a Unix disk. It's not a Windows disk. It's a Unix disk. It's 2 terabytes. Okay, I'm going to move this from one computer to another computer. I made it on the computer over there. I'm going to move it to the computer over there. Okay. Now, what happens if D. Mandel was 44444 on that computer, but where this got made, but when I go over there, D. Mandel is 44345. Guess what? I can't access my files. They belong to Susie because because all it says is the UID of who those files belong to. Or if I share things through an NFS mount, a disk drive from a remote system, I get screwed up if those UIDs change. I think there's a mapping system, or at least there used to be a mapping system. Maybe it doesn't exist anymore. You don't want to use it. Not unless you have to. Sometimes you have to. But what I'm saying is every place I've ever worked, I was really, really careful in keeping track of people's UIDs and GIDs, making sure that they are the same across the entire network, and they're the same across the entire network. And when people leave, I don't delete their. I don't tend to delete their username because those files are still around using that UID number. If I did delete that, then I'd have to make sure that all their files got changed to a new appropriate UID or ID. I'm just saying that managing the UIDs and GIDs is really an important thing. And the way I do it is really pretty easy. It's straightforward, it's easy. The only time you get into real trouble is when you acquire another company and you merge two companies together and they didn't use the common pattern, and you get conflicts every place. And then, you just have to resolve those. Those are going to be a pain. And that happens. But especially when, research groups work together. If you're at Oregon State University, you're working with people from Scripps, and you're working with people from Woods Hole, and you're all sharing your computers. Things happen, and you just have to deal with it. Although often it's pretty straightforward. Okay. Whoops. Well, try adding some users and deleting them if you want. But remember what I said about delete. Also, the shadow file is an important file. We will go down here. And you notice that in the password file, they do not store the password. The password should be stored where that X is. In ancient times, they used to store the password as an encrypted password there. And then people would figure out how to decrypt the password. So instead, and the reason for that is the access rights on password file. The access rights are read, write, and anybody can read that file. Even other can read that file. And so, everybody's got access to that. Okay, so they have gone instead to put an X in that slot, and they have another file called shadowed. And notice its access rights. Most people have no rights to that file. Of course, we have rights to that file, so let's take a look at that file. Okay, what that file has I don't want that. what that file has is it has the encrypted password, and it has lots of information about things like expiration date. You can make things expire after a certain date. This is all talked about in the textbook. I do not use most of those things. Most people don't use most of those things. Some big organizations do. But the shadow file is crucial because it hides your encrypted passwords. Let's look at this guy once again. Let's look at, oh boy, I don't know if I can find that. Here's the password command. The password command has a funny thing here that I don't know what it is. It's got access rights like I've never seen. They're supposed to all be RXW or something like that, but this guy's got an S in there. Notice that little S? That's called a set UID file. That's just a very special access right, and that means when I execute the password command to change my password, any user is allowed to execute that password command. That password command has to go into the shadow files /etc/shadow and change the encrypted password because it's got to put in the new password. Okay, to do that, this command, that S, basically says that the ordinary user that executes that command becomes root for the duration of the command. So the ordinary user has root access rights to change the password. That's important. Now, so that means if I'm worried about system security, one of the things I need to worry about with system security is I need to look at all my set UID files every now and then. Because suppose there is a bug in the password file where you can exit some which way through the password file. If I type in the proper password, it just takes me to a shell. What shell is it going to take me to? The root shell. So if I'm a bad guy trying to do bad things on a system, one of the files I would really like to figure out how to change is the password file. Because if I can put a flaw in that program, it will give me access, a backdoor to the whole system. So one of the things that system security people look at, or systems administrators, because we're not computer security people, but we do an awful lot of computer security because we got to secure our own systems. One of the things we look at is we look at all the set UID files on the system and make sure that we don't have, make sure they didn't get changed, and make sure that there's no set UID files on the system that we don't know about. There's also a set GID files, but it's the same idea. Okay. Well, we did not do chapter 7. Well, I guess we did. Create, manage, and new local accounts. We didn't really talk too much. We did talk about sticky bits and set UID. We didn't talk much about permissions, though. Permissions are really, I mean, that's the heart of your security system. Unix uses a really dumb security system, and I say that with great admiration. It's elegant. I came from a system that they used an access control list system, ACL system. And I thought you really needed an ACL system to get good security. And I looked at Unix and this dumb system with just twiddling a few bits, like 3 bytes of information. It's like not even that much. It's the result is checking access rights in Unix is very, very fast because the CPU has to do no work, very, very little work. Whereas the traditional control access control access ACL type systems like Windows has, there's a lot of overhead to checking everybody's access rights. They can get very, very fine grained, but there's a lot of overhead. The Unix ones, there's very, very little overhead. It's a little cruder, but when you think about it, it will do everything you really need to do. There is an ACL-based system that you can put on top of Unix or on top of Linux, but I've never needed it. Of course, I work on scientific systems, but I've never really needed it. And I think if I did need it, I wouldn't. At that point, I would need a database management system that would take care of all my access rights anyway, so I wouldn't need it. Anyway, what I wanted to say is learn to use the user access system. It's elegant, it's brilliant, it works well, and it will do most everything you want to do. Okay, it's getting up towards 11 o'clock. I am running about 9 minutes late here, so that's enough for today. I'll be around for, until about noon. And let me cancel the recording.